In this problem, we need to determine the equation of the circle that is tangent to the y-axis at the point 0, 3, and it has an intercept of 8 units on the x-axis. So let's try to understand the problem graphically first. So here we have a Cartesian plane with the x and the y-axis. We consider a circle having a center C, and this circle is touching the y-axis, that means it's tangent to the y-axis at the point 0, 3. So let's name it as point A, having coordinates 0, 3. And it has an x-intercept of 8 units. That means if we consider this as a point B and this point C, then the length BC, which is also the chord of the circle, so the length is 8 units. Now using this information, we need to determine the equation of the circle. Now, a few things that we need to know that before finding out the equation of a circle, we need to create key information, one being the coordinate of the center C, as well as the radius of the circle. So let's try to find it out. We will begin by first constructing few perpendiculars here. So from the center C of the circle, we're going to drop a perpendicular on the line BC, or on the x-axis. Now let's call it the point E. Now we know that a perpendicular drawn from the center of a circle to any chord intersects the chord. So that means that we have CE perpendicular to BC. So this is going to give us the length B. So BE is going to be half of BC. Now since BC is 8 units, so we have 8 over 2, which gives us the value 4 units. The length of BE, which is also equivalent to the length of EC, that's going to be equals to 4 units. Now we have this information, so let's note it down. So we have BE equals to 4 units. Now since the circle touches the y-axis at point 0, 3, if we draw a line from the center and it is perpendicular to the y-axis or perpendicular to the tangent, then it immediately tells us that the length of CE, this height, is going to be exactly equals to 3 units. Fine. So we get this information as well. So length of CE is going to be equals to 3 units. Now that we have the length, we will try to find out the radius of the circle. The radius of the circle, which is given by CB, so we will consider the right angle triangle CEB. It is right angled at E. Using the Pythagoras theorem, we have CB squared equals to CE squared plus BE squared. So this gives us the value. So CE value is 3. So we have 3 squared added to BE squared, which is 4 squared. Now we're solving this, we get 5 squared. So CB squared comes out to be 5 squared, and that means we have CB equals to 5 units, and CB being the radius, so our radius of a circle comes out to be 5 units. Now if CB is 5 units, then length of CA, which is also the radius of the circle, that must be also 5 units. Now we can define the coordinate of the center C. The x coordinate is going to be the length 5 units, and the y coordinate is going to be the height CE, which is 3 units. So we have the center of the circle as well as the radius of the circle. So let's try to find out the equation of the circle using the standard form. That means if we have a circle whose center has the coordinate h, k, and the radius given by r, the standard form of a circle is given by this particular equation, which is x minus h whole squared plus y minus k whole squared equals to square of the radius. Now coming back to our problem, we have found out that the coordinate of the center is 5, 3, and the radius of the circle is also 5 units. Now we can use the standard form. So using the standard form, we have x minus h whole squared plus y minus k whole squared equals to the square of a radius. In our case, we have obtained that the coordinate of the center, which is given by h, k, this value came out to be 5, 3. This implies that the value of h is going to be 5 units and the value of k is going to be 3 units. And the radius, which is defined as equals to 5 units. So this gives us x minus 5 whole squared plus y minus 3 whole squared equals to the square of the radius. So this is going to be the standard equation of the circle, and if we want, we can further simplify this to get x squared plus y squared minus 10x minus 6y plus 9 equals to 0. Now, the question is this the only circle that's possible? No, there is also another circle that's possible. So let's try to understand that as well. Now, according to the problem, it says that the circle must touch the y-axis at the point 0, 3. That was the first part, and the second part was that it has an x-intercept of 8 units. Now, the circle could be also lying on the second quadrant. Now, this circle is also following the criteria that it touches this circle at the point 0, 3, and the length of the chord or the length of the x-intercept is also going to be 8 units. So we'll have another circle as well. In this case, the coordinate of the center, let's call it C prime, it's going to be -5. Since it's the mirror image of the yellow circle, so it's going to be -5, 3. We have flipped it about the y-axis. Now the radius is going to remain the same. It's also going to be 5. So that means the equation of this circle is going to be x plus 5 whole squared plus y minus 3 whole squared equals to the square of the radius. Right, and this one we have already obtained. It is x minus 5 whole squared plus y minus 3 whole squared equals to the square of the radius. So these are the equations of the two circles.